There's no, yeah. Lucky you guys. Okay, a population of insects has a population of 400 individuals. Insects are now individuals. Okay. On May 31st. Make sure you follow along. May 31st. Why is that given to me? It might be irrelevant, it might not be. Okay? Use this day as day 0. The population doubles every 14 days. You should probably have a doubling time scenario, an example on your study sheet, and a half-life. I'm just saying that's it would be very good for you. Create a table of the number of insects for the initial and 3 doublings. Okay, let's do that. We've got time and we've got population. You need to come up with your equation, right? So at time 0, please don't forget that, at time 0 we have 400. 14 days go by. We're going to be at 800, right? You double this. There's no doubling on the left side, please. There's no doubling here. Another 14 days go by. That means we will be at day 28. Our population doubles again. Okay. Another 14. So this is one doubling. This is a second doubling. And it asks us to do 3 doublings. Technically, this would be all you need to do a regression, but it asks us to do it one more time. That would be 42. And so you double your population again. What happens on the left side? I go plus 14, plus 14, plus 14. And you know what? The honest reason why I made you do 3 doublings is for you to see, because students are like, no, wait a minute, Mr. Erickson, look at doubles. You go from 0 to 14. 0 times 2 is 0. But some students miss that. If you go look, Mr. Erickson, it doubles. 14 times 2 is 28. See, it doubles there too. But does it double again here? 2 times 28 should be 56, right? It is not. So on this side, you're just adding your doubling time. But the doubling is actually happening to the population. Okay? This is the power of investing as well. Your money grows slow at first, but then it's just like a exponential effect after that. It just goes up really fast all of a sudden. Okay? So we did the table. Okay, good. Determine the equation. That's B. L1, L2. So for B, we go stat, calc, exponential regression. We figure out our regression. So let's do that. Stat, edit, clear everything. You know how to clear, right? You go to the top, you hit clear, enter. Don't hit delete. Here we go. 400, 800, 1600, 3200. There we go. I'm checking, nothing wrong. I typed in everything right. Perfect. You want to look at your scatter plot? Sure. We go to y equals, we turn on plot 1, and we go zoom stat. And it does look exponential, right? It looks exponential. Let's do the regression. Stat, calc, exponential, you got to go all the way down until you see it. And then at second 1, comma, second 2, comma, alpha, trace, close your eyes, just press the buttons, right? You know that already. You're probably having dreams of alpha 1, alpha trace. This is 400, no surprises there. 1 point. I'm just going to do this. You don't have to. You can round to 2 decimals on a test, on an exam, you'll be fine. To the power of x, okay? Can you tell that this is increasing? Absolutely, right? We knew that anyways. We're increasing, we're doubling. But this is telling you what it is per period. So what is our time measured in, it's days. So you can tell that it's going up by 5.08% per day. Just in case you missed it. I'm going to go 1.0508 minus 1. That's 0.0508. If you multiply that by 100, you've got 5.08% increase per day. Where did I get the per day from? That's what time is measured in here. So if it's in hours, this would have been per hour. So I don't want you to forget how to do this, okay? That this is always there, and there we go. C. How many insects will be present on June 30th? How do we do this? What is time 0 for us? That's May 31st, right? So we need to do a little bit of calendar backwards thinking in this case. What do I have here? So for time, May 31st is time is equal to 0. Okay? That means that June 1st is what? Time would be 1. X is 1. So if it says June 30th, what should X be? I'm going to go dot, dot, dot. June 30th. Time is 30, because we're saying May 31st is time 0. So therefore, June 30th is time 30. X is equal to 30. Therefore, it's asking really, when X is equal to 30, what is my population? We're going to go second trace, intersect. No, sorry. Value. X is equal to 30. Y is equal to 1,766.54. Can we answer like this when it's population? No, you got to round in this case. Okay, always think, what is this in? So roughly 1767. There we go. What are we talking here? Insects. You could have gone 6.6, but that would have we would have missed out on 6.7, right? So why would we do that? So as long as it's the whole number, the province is okay. Okay. D, how long? How long will it take for the population to reach 10,000? 10,000. So it's basically how long to get to 10,000. That means that we need to let y2 equal to 10,000. Second, trace, intersect. And I'm giving you a warning already. Your window is probably going to need to change for this one. It may not need to, but I'm pretty sure it's going to have to change. So let's go ahead and try that. Y2 is 10,000. I don't see it. So you've got two options. Change your window or try zoom fit. I'm just going to change my window because I know that my Y max should be, I'm going to go 15,000. And I can still not see it. I need to keep chasing it to the right. So I'm going to increase my X max as well. I'm going to go 100 there. It was 46. I'm going to go to 100. As long as you see them meeting, you're fine. Second, trace 5, intersect 65.01. X is 65.01 days. Can I have 0.01 of a day? The answer is yes. As weird as it sounds, yes. Because You can go down to hours if you need to, or minutes, or seconds, milliseconds. You can keep going down. So time, if it's in days, it's fine to get it as a decimal. That's it. Domain and range. It doesn't ask for it. What's domain? Time 0, 2. Does it give us a stop? It doesn't say it stops growing. The insects stop growing after a certain time in this case. So you just go infinity. Range. What's the lowest that I go in terms of population? 400, right? 400. And I keep going indefinitely. So, for your homework, I'm going to say 14 to 17. That's just equation given. So you do not need to come up with a regression or anything like that, okay? Then I'm going to ask you to do page 19. Let me just check. I think it's page 21 as well. Sorry. Yeah, 21 as well. Page 19, 21, regressions. Use the rest of today's class